Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Essam Al-Ghumgham. I'll be presenting to you a lecture named Lessons Learned from 100 Intelligent Wells Equipped with ICVs. We're starting with the outline. We'll talk about the introduction to the inflow control valve, and then over all the findings, and after that we will talk about potential improvements and finally conclusion. Well, this is a schematic diagram for the ICVs. We usually use the ICVs in heterogeneous formations with the variations of the fluid properties and the rock properties as well. So, and a brief definition for the inflow control valve. They are multi-position active valves that can be controlled from the surface. The overall findings can be summarized by the following points: sustaining the productivity, improving its sweep, controlling overflow from multilaterals, and managing water and minimizing production interruption. We're talking about the productivity variation among laterals. This reveals that the closer the lateral to the heel, the more production is obtained, and further the opposite. And so why that's basically due to the friction losses as you get further from the heel, and that can be shown directly from this schematic diagram. We can see if this is the multilateral commingled system, you see that the closer the lateral to the heel, we see that we obtain more production, and the opposite is right. So we can see that the mother pore is producing the need. So talking about the prolonging the well life, let us consider a well A, which is located in a heterogeneous zone with irregular water movement. So what we do is we control the ICVs in such a way to make the balance on all the lateral production in such a way to reduce and cut off the water cap, and hence increase the production. And talking about managing withdrawal and optimizing the sweep, let us consider a well B, which is located in an area of controlled injection and uniform sweep. So comprehensive tests show that the upper lateral is producing the most, and hence we have to control its flow in such a way to not create a big drawdown on the well. That can be shown from this chart. We can see that the upper lateral, which is labeled L2, is producing the most. And after we adjust the ICVs, we could obtain all the laterals to produce at almost the same rate. In maximizing the production rate, let us consider a well C, which is a dry lateral well producing at a very high drawdown. So this is what we don't want, the high drawdown. So what we do is, we put restriction on the lateral in such a way to make the most producing lateral more restricted and decreasing up to the less producing, and hence we can shift from this stage with low productivity to higher productivity and with lower drawdown. So the bottom line of this slide is, to manage the withdrawal in homogeneous reservoirs, we could use the ICV by understanding the concept that when water or gas break down into any interval, the ICV role becomes essential in eliminating or reducing the production of water or gas to increase the production of oil. Minimizing the cross flow among the laterals in heterogeneous reservoirs. That can be illustrated from the next diagram. We can see by editing the choke, we can manage the water coming inside. So here we can see it's 42 in the main bore. We see here the negative percentage, and here the negative percentage. While in here it's something optimum, we could see the percentage is positive. That means that the water is not breaking down. With double gas functionality and capability, once a completion is set and a well is put on production, it is expected to do a routinary functions test and these completions. However, with the lack of the testing facilities and surface control systems for these wells, it would be hard to decide or optimize the performance and expect the benefit. Solution. The solution would be improving the design of the downhole valves, which enable the adjustment of distribution of airflow among different laterals that shall allow better management. So the potential improvements could be the cost of flow prevention, which is closing all the ICVs. Time's up. Well, let's go to that conclusion. Well, using the ICVs, we could obtain and construct flow rate from all laterals and lengthen the well life and optimize the sweeping and maximizing collection rate and minimizing cost of flow and managing the well drought. So this is the end of my presentation. I will be happy to accept any questions.
Good presentation.
I didn't practice for it.